Well played. Well played. Alright, warm it up. Tell me, solution, not a solution.
Not a solution. How is not a solution?
Need glasses. Never mind. He was gonna say because he was.
Okay, why not a solution?
Because
40 does not have negative. If you plug it,
Go ahead, Sid.
if you plug in the point into either one, it's not gonna come out correctly.
You sure?
Wait, sorry. It doesn't work for the 3x plus 4y equals -7.
But it does work in the other one, right? Okay, so we can't just go that it doesn't work in any of them, because it actually works in the second one.
It doesn't work in one of them, therefore
but it doesn't
work at all.
Exactly. But because it doesn't work in one of the two, it's technically not a solution to the system. Okay? So if we said here 3 times 4 plus 4 times 7, and that's got to be -17, or 5 times 4 minus 10 times 7, and that's got to be -50. So over here, we get 20 minus 70, which is -50. That one works out because -50 is equal to -50. So we're good there, but if we would have tried it in this one, 12 plus 28 is not -17. So not a solution. Okay. Checking your answer, and that's basically what a question like this is. It's checking your answer. You got an answer, you got to check it back in. That's all that this boils down to. Okay. Today and this week, what we are going to do is we are going to take it up another notch. And by taking it up another notch, now instead of 2 equations with 2 variables, we are going to have 3 equations with 3 variables. Okay? So we have to go a little higher, do more stuff. What's
I
up?
just had a quick question. So, if we ever see a problem like that in the future, would you want us to show our work for plugging in for both equations or not?
Nope, it all depends on which one you start with. Yeah. Yeah, as soon as you get one that it doesn't work in, then you're done. If you got one that where it worked in, you have to go to the next one. Yeah. Okay. So now what we're going to have is we're going to have ordered triples because we've got 3 equations with 3 unknowns. So an ordered triple looks like this. It's got 3 numbers inside the set of parentheses. Again, alphabetical inside there, so that means that 7 is X, 1 is Y, and -3 is Z. Yes, you got to go on 3-dimensional so it comes out. If you think of the your paper as like normal graphing, what we've done, the z-axis would come straight up. Yeah. Okay. So if I'm asking the question, find the ordered triple, or is the ordered triple a solution, we would plug it into 2 times, so x is 7, that was blue, plus 5 times y is 1, that was green, plus 3 times z was -3, that was purple, and that's got to be 10. Well, 2 times 7 is 14, plus 5 times 1 is 5, plus 3 times negative 3 is negative 9. It's got to be 10. 14 plus 5 is 19. Minus 9 is 10. So that one works out. So we got to go to the next one. We got to go to the next equation to see again if that works out. Come on now. There we go. So we'd have 3 times x minus y plus 4 times z, and that's got to be 8. 21 minus 1 is 20. 4 times negative 3 is negative 12. 20 minus 12 is 8. 8 is equal to 8. So it works out in that one. So then we got to go to the third equation and try it in that one. 5 times 7 minus 2 times 1 plus 7 times negative 3, and that's got to be 12. 5 times 7 is 35. 2 times 1 is 2. 7 times negative 3 is negative 21. 35 minus 2 is 33. 33 minus 21 is 12. And 12 is equal to 12. So it works out in all 3 equations. So therefore, yes, 7, comma 1, comma negative 3 is a solution. Today, what I'd like to do is I would like to get into one of the methods that we use, and we're gonna start with substitution. We're gonna get into how to actually solve a system of 3 equations with 3 unknowns. Now, I'm not gonna lie to you. This problem is long. Problems like this are long. Sometimes you get lucky and the first step makes it go a little easier. Sometimes you get not so lucky and the first step makes it ugly. It happens. It's luck of the draw. Okay? But what I mean by that is don't try and cram this problem into like 2 lines on your paper. These problems need some space to breathe, need some area to work, need some area to write stuff down. Okay? 5 steps. 5 steps. Okay? So using substitution. Now substitution, when we were doing it last week, solving systems of equations, 2 equations, 2 unknowns, what did we do first last week with substitution? Got one of the variables by itself. Then what do we do? No. Got a variable by itself first. Stick it into the other equation. Right? Then solve. Then
Check. Sorry.
nope, not yet.
Or you stick that back into the other, into the same.
Got whatever variable, found the other variable, and then checked it. Okay, so 5 steps last week, 5 steps this week. What do you think the first step's going to be? We're going to get one of the variables by itself. Now, last week we had 4 variables to choose from. Usually we had 2 x's and 2 y's. Well, now I've got 3 x's, 3 y's, or 3 z's to choose from. So I got 9 choices of which variable I want to get by itself. Okay? Let's be smart. Let's work smarter, not harder. What would 3 really good choices be for variables to solve for?
X
Where?
in the bottom equation.
In the third equation?
Yeah.
Okay. I do also like to number my equations. Okay. So I would call this equation number 1. And I use Roman numerals because then it doesn't get confused with coefficients. Okay. So the third equation for x would be a good choice. 2 more. Second equation for z would be a good one. First one for y would be a good one. All of those are smarter, not harder variables to solve for. Doesn't matter which one we choose. No, pick one.
X.
X, you want to solve for x. Okay? So we're going to solve equation number 3. So this is step number 1. We're going to solve equation number 3 for x. If I do that, I get x equals 7 minus 4y minus 3z. Last week, what did we do for step 2? Plugged it back into the other equation, right? This week, now what are we going to do? We're going to plug it into both equations. So we're going to take that which we just solved for, and we're going to plug that into both of the equations that we just had. So if I go into equation number 1 first, I would have 3 times my x value now is 7 minus 4y minus 3z plus y minus 2z equals 10. So that's 21 minus 12y minus 9z plus y minus 2z equals 10. So that becomes negative 11y minus 11z equals negative 11. And I'm going to call that equation number 4. Now I have to stick that x into equation number 2. 6 times 7 minus 4y minus 3z minus 2y plus z equals negative 2. Negative 26y minus 17z equals negative 44. with me so far? Questions, comments, concerns, clarifications up to this point? Okay. Next, what we're going to do now is we're going to use elimination or substitution, or if you really wanted to graph it, you could graph that on our two new equations, equations 4 and equations 5. So, what would you like to use? Substitution or elimination?
Which one would you do?
Well, you're looking at equations 4 and 5. So, my go-to jam is elimination, right? But if I'm looking at eliminating the y's, I gotta either multiply, 11 and 26 don't have any common factors. Look at z's, 11 and 17 don't have any common factors. Okay? So, we could do substitution, okay? Or we could, still do elimination, but it's just gonna have bigger numbers. Okay? So we want to use substitution. So what variable do you want to solve for in substitution? Solve equation number 4 for y. Okay? So that would be negative 11y equals negative 11 plus 11z. And then I would have to divide everywhere by negative 11. And that's going to give me y equals negative 11 divided by negative 11 is positive 1. Positive 11 divided by negative 11 is negative 1 times z is negative 1z. Then I've got to replace y in equation 5 with that. Z negative 18. So z equals negative 2. One minus negative 2 is positive 3. So we have y and z, yes? Okay. So now we just need x. So what we're going to do is we are going to plug those two variables back into one of our original equations to get our third variable. So I would probably go with equation number 3, because equation number 3 has just x by itself. X plus 4 times y, well, y is 3, plus 3 times z, z is negative 2, and that's got to be 7. plus 12 minus 6 equals 7. X plus 6 is 7. So X is 1. Lastly, what we're going to do is we are going to check our work by plugging in all three variables back into all three original equations. And then we'll write our answer as an ordered triple. So equation number 1 was 3x plus y minus 2z equals 10. If I plug in x is 1, then I get 3. If I plug in y as 3, I get plus 3. If I plug in z is negative 2, I get positive 4 there. And that's equal to 10. Equation number 2 was 6x, minus there, minus 2y plus z equaling negative 2. Bad 2. Oh, snap! Hit the wrong button. Scared there for a minute. 6 times 1 is 6. 2 times 3 is going to be minus 6. And negative 2 is going to be negative 2. Oh, and that gives me negative 2 equals negative 2. Checks out there. That's a good thing. A lot of work. Don't want it to all of a sudden make one little mistake. Third equation. Third equation was x plus 4y plus 3z has to equal 7. X plus 4, so x is 1. 4y would be 12. 3z, somebody's phone's off the hook. Yeah. 3z is negative 6. 1 plus 12 is 13. Minus 6 is 7. 7 equals 7. So it checks out in all three. So our final answer then is 1, 3, negative 2. Good times. Questions, comments, concerns, clarifications? Alright, what I'd like you to do now is I'd like you to try one on your own. Go for it. Of the 9 variables, really there's only one choice to solve for, and that's solving equation number 3 for y. So if I solve equation number 3 for y, I get 6x plus 4z plus 1 equals y. Plugging that back in then to equation number 1, 4x plus 2 times that gets me 6x plus 4z plus 1, then plus 3z equals 1. So that's, let me scroll this up a little bit. 4x plus 12x plus 8z plus 2 plus 3z equals 1. 16x plus 11z equals negative 1. We'll call that equation number 4. Then if I go into equation number 2, 2x minus 3 times 6x plus 4z plus 1 plus 5z equals negative 14. 2x minus 18x minus 12z minus 3 plus 5z equals negative 14. Negative 16x minus 7z equals negative 11. Call that equation number 5. Then if I add 4 and 5 together, I got 16x plus 11z equals negative 1, and negative 16x minus 7z equals negative 11. Add those two together because it's set up for elimination. That gives me 4z equals negative 12. So that gives me z is negative 3. If z is negative 3, then we can go back into 16x plus 11 now times negative 3 gives me negative 1. 16x minus 33 equals negative 1. 16x equals 32. X is 2. If I go all the way back to my originals, 6x plus 4z plus 1 is y. So 6 times x is 2 plus 4 times z is negative 3. So that's 12 minus 12 plus 1. 1 is 1. First equation was 4x plus 2y plus 3z equals 1. 4 times 1 is 4. 2 times negative, excuse me, whoa, tap the brakes, I was going off of x. 4 times 2 is 8. 2 times 1 is 2. 3 times negative 3 is negative 9. 8 plus 2 is 10, minus 9 is 1. Checks out in the first equation. Second equation was 2x minus 3y plus 5z equals negative 14. 2 times 2 is 4. 3 times 1 is 3. 5 times negative 3 is negative 15. 4 minus 3 is 1. Minus 15 is negative 14. Third equation. X minus y plus 4z equals negative 1. 6 times 2 is 12 minus 1 plus 4 times negative 3 is negative 12 is negative 1 equals negative 1. Checks out. Final answer 2, comma 1. Negative trace. Questions, comments, concerns, clarifications? They're long, I get it, but that doesn't give you the right to just quit. Okay? You can do it. The math isn't hard. There's just a lot of it. Okay? The actual math is not that hard. Okay? Just because your problem, the one problem might take half of a page, let it take half of a page. Okay? No big deal. Okay? Alright? The more you practice this stuff, the better you'll get at it. Okay? I remind you that tomorrow there is a formative assessment in the MRC, along with the fact that you've got these 5 homework problems due on Wednesday.